This is cm2900 sample paper question 2. We're given that v equals natural log of x squared plus y squared, and we're asked to show that the sum of the two second order partial derivatives with respect to x and y respectively is equal to 0. So we need all the partial derivatives. So partial dv by dx, we get using chain rule. So the outer function is natural log, and the derivative of natural log is 1 over the argument of the natural log. So partial dv by dx is 1 over x squared plus y squared. That's the argument of the natural log, or what's in the brackets. But chain rule says we must then multiply by the contents of the inner function, the bracket. Well, derivative of x squared plus y squared with respect to x is 2x. So times 2x, which of course could be written as just 2x over x squared plus y squared. Then partial d2v by dx squared is the derivative of this expression, and we have to use the quotient rule here. So quotient rule says that f upon g differentiated, which I indicate with a dash, is given by f dash g minus g dash f over g squared. So in our case 2x is f and g squared, g is x squared plus y squared. So derivative of this with respect to x is f dash, derivative of 2x, which is 2, times the bottom, which is g, minus the derivative of the bottom with respect to x, which is 2x, times the top, so times the other 2x, all over the original denominator squared. Now partial dv by dy, by similar reasoning, is going to be 2y upon x squared plus y squared, and therefore partial d2v by dy squared is very similarly, derivative of the top with respect to y is 2 times the bottom minus the derivative of the bottom with respect to y is going to be 2y times the top, all over the square of the original denominator. So we were invited to show that the sum of these two second order partial derivatives is equal to 0. Well, just shift things around slightly here. So we have the sum of these two is therefore given by, well, we've got the same denominator in both cases, and if that's the case, all we have to do is write down one denominator and simply add the numerators together. Well, if we expand this, work out the bracket, we get 2x squared plus 2y squared minus 4x squared And from this one we get 2x squared, so plus 2x squared plus 2y squared minus 4y squared. And then we can see that a ring, so it cancels out here. 2x squared plus 2x squared is 4x squared, minus 4x squared is 0. 2y squared plus 2y squared is 4y squared, minus 4y squared is 0. So our numerator comes to 0, and 0 divided by anything is just 0.